Welcome to a new episode.
Hello and welcome back to the Copper Connection podcast with me, as always, your host, Chris Bailey. Last week we went through all in paper one: health and safety law, the construction industry, design, sustainability and building technologies. So you've got the big picture of how construction works. This week, the spotlight moves into paper 2. No distractions, no mixing up specs, just the systems and safety knowledge that keeps people alive when something goes wrong. We're going to zoom in on emergency procedures, fire safety, alarms, gas and electrical emergencies. The stuff you're expected to know in the exam. And it's stuff you'll be glad you know if the fire alarm ever sounds for real. So whether you're on site or on a bus or in the workshop, this is your Part 2 Emergency Safety Revision Session. Settle in and let's get into this week's episode. Let's start with the bit that most people think they understand until they get examined on it, and that is fire alarm systems. In most commercial and large residential buildings, a fire alarm system is built around a fire alarm control panel, often called the FACP. That panel is connected to detectors that detect either smoke, heat or multi-sensor heads around the building, manual call points, the break glass units you hit when you see a fire, and the alarm circuits, sounders and visual indicators like bells, sirens and beacons. The panel is normally powered from the mains and has a backup battery, so the system can still operate if the supply fails. That's important from both a safety and exam point of view. If you see a question about power failure during a fire, you should be thinking there should still be an alarm because of the battery backup. A manual call point is essentially a simple switch with a resistor in series. When someone activates it, current flows at a particular level and the panel recognises that as fire in that zone. The panel then will trigger the alarm sounders and beacons, indicate which zone or device is in alarm. In some setups, automatic operations link systems like releasing magnetic door holders, dropping fire shutters, or returning lifts to the ground and then parking them. Think of the panel as the brain. Detects and call points send its signal, and it decides which outputs to activate. So revision checkpoint, answer these in your head. What provides power to an alarm system if the mains fails? What's the job of a manual call point? Give one example of another system the fire alarm might automatically trigger. Okay, so knowing the technology is only half of the job. Paper 2 also cares about whether you know what people should do when that technology kicks off. In an emergency, especially fire, the basic sequence is simple but must be followed consistently. Number 1, we raise the alarm. If you discover a fire, you shout, you hit the call point, you follow side procedures. The goal is to alert everyone as quickly as possible, not to be a hero trying to tackle the fire on your own. Number 2, stop work and evacuate. So it's tools down, machines off, if safe to do so, and move. Don't go back for your bag, your lunch, or your favourite spanner. Fire and smoke move faster than you think. Number 3, follow the escape routes. Use the marked fire exit routes and stairs. Never use the lift during a fire unless you're in a building with a specific firefighting lift. Follow the green running man signs, not your usual shortcut. Number 4, close doors behind you. If you can safely close fire doors on your way out, do it. It slows smoke and flame spread and buys time for other people. Number 5, go straight to the assembly point or muster point. Don't wander around the car park, go to the marked assembly point and stay there. That's where a roll call or head count can be done. And number 6, await instructions. Normally from a fire marshal, site manager or emergency services. You do not re-enter the building until you're told it's safe. In exam questions, you'll often see a scenario. You're working in a plant room, the fire alarm sounds, what should you do? Marks come from showing you understand the sequence: alarm, escape, assembly, and then follow instructions. Next up, following on, is fire classes and fire extinguishers, a classic exam favourite. Fires are grouped into classes based on what's burning. So we have Class A. This is used for solids like wood, paper or textiles, or often likes to be referred to something organic. Class B, flammable liquids like petrol, solvents or paints. We have Class C, which is for flammable gases. Class D for metals such as magnesium or aluminium shavings. And Class F is cooking oils and fats. On top of that, we talk about electrical fires, where live electrical equipment is involved. Extinguishers then have a colour band. That tells you what's inside and what class they're suitable for. So we know the good old classic red fire extinguisher is water. Only to be used on Class A. Never used on electrical or flammable liquids because you could actually either electrocute yourself or cause the liquid fire to go further. Then we have cream, which is foam, good for Class A and Class B, and again, not suitable on live electrics. We have blue, dry powder, can be used on classes A, B and C, and sometimes electrical fires. Versatile, but can create visibility and breathing issues in enclosed spaces. And then we have black, the CO2, carbon dioxide, mainly used for electrical fires and some Class B fires. This leaves no residue and good for protecting electrical equipment. And then we have yellow, wet chemical. This is designed for Class A fires. Deep fries, cooking oils can also be suitable for some Class A fires. A very common question is which extinguisher would you use on an electric fire? The safe answer is CO2, black label, or the correct type of dry powder. Not water, not foam, and definitely not wet chemical, unless the equipment is de-energised. Okay, so quick test yourself right now. Which extinguisher colour is used for electrical fires? Which extinguisher is designed for cooking oil fires? What class of fire is burning paper and timber?
Follow us where you get your podcasts from.
Paper 2 leans more heavily into systems, so you need to join your emergency knowledge to gas and electrical installations. Let's start with a suspected gas leak. Don't operate any electrical switches. No turning lights on or off. No plugging or unplugging. Switching can create a spark. If it's safe, open a door and a window to ventilate the area. If you're trained and it is within your role, isolate the gas using the emergency control valve at the meter. Evacuate the area, keep people clear and call the gas emergency number. Gas work itself must only be done by gas-registered engineers, but as a BSE learner, you are expected to know these basic emergency steps. For electrical emergencies, like an electric shock, please do not touch the person if they're still in contact with a live conductor or equipment. If you can isolate the supply, usually at the consumer unit or the main switch off, once you're sure the supply is isolated, only then can first aid or CPR be attempted by someone who's trained. The incident must be reported and recorded according to workplace procedures. For fire electrical, remember, do not use water or foam extinguishers on live equipment. Use CO2 or suitable dry powders and isolate the power supply if it's safe to do so. The exam isn't asking you to be a paramedic. It's checking that you don't make a dangerous situation worse. Safe isolation, correct extinguisher, choice and clear emergency steps will always earn you marks. And finally for this episode, let's pull in some of the protection systems from your BSE system content, like the intruder alarm, CCTV and access control. Intruder alarms often use detectors, door contacts and PIR sensors connected back to the control panel. They might trigger bells, sirens, flashing lights or send a signal to a monitoring centre. CCTV uses cameras, recorders and often works with other systems like access control and alarms to protect people and property. And access controls who can enter certain areas. Think keypads, proximity cards, fobs or biometric readers like fingerprint scanners. In an emergency like a fire, access control systems may release doors to allow evacuation, and CCTV can help emergency services understand what's happening. For paper 2, be ready to describe the purpose of each system and explain how they support safety, not just security. Okay, so that's your deep dive into emergency procedures, fire safety, and we've touched on protective systems for T Level BSE Paper 2. Last week was all about the big picture for Paper 1. This week was focused on how you react when things go wrong, alarms, evacuations, extinguishers, gas and electrical emergencies, and the systems that keep people safe. If any part of today's episode felt a bit shaky, jump back to that section, listen again, then grab your revision notes and try the now test yourself questions around fire alarms, extinguishers and emergency actions. The goal is for these steps to become automatic in the exam and even on site. If this has helped your revision, share the episode with a course mate or site WhatsApp group. And make sure you're following the Copper Connection podcast so you don't miss the next Paper 2 session. You're not just chasing a pass, you're building the kind of safety knowledge that generally saves lives. You've been listening to the Copper Connection podcast. I've been Chris Bailey, and we will catch you on the next episode.
Welcome to a new episode.
Hello and welcome back to the Copper Connection podcast with me, as always, your host, Chris Bailey. Last week we wrapped up Paper 1 from safety legislation and industry roles to how buildings are designed and put together. In the last episode we kicked off the Paper 2 with emergency systems and fire safety. Today Paper 2 stands front and centre, but we're widening the lens. We're going to look at the science behind what you do, how you measure and manage information, how businesses and maintenance decisions affect your work, and how all that connects back to BSE systems, heating, hot water, gas electrics, and more. If Paper 1 was about understanding the building, Paper 2 is about understanding how your decisions affect performance, safety, and cost over time. So grab a brew, settle in, and let's get into this week's episode.
Bridging the gap with questions from you.
First up, some of the construction science that sits behind your BSE work. This is where calculations and physical principles turn into marks in the exam, and even better, decisions on site. You'll see a lot of SI units and derived units. So we have length in metres, area in square metres, which is your length times your width. We have volume in cubic metres, which is length times width times depth. We have force in newtons and energy in joules and power in watts. These feed into everyday BSE tasks. For example, when you're sizing a room's heating requirement, you must use the specific heat capacity of water and calculate energy using volume, temperature rise, and the 4.2 kilojoule per kilogram per degree figure. Mechanically, you also need to understand mass and weight, linked by gravity, work done, which is force times distance, power, which is work done divided by time, efficiency, output power delivered by input power as a percentage. And then there's basic electrical science, voltage in volts, currents in amps, and resistance in ohms. Ohm's law is voltage equals current times resistance, difference between series and parallel circuits, the role of protected devices, fuses, circuit breakers, RCDs and RCBOs, which disconnect circuits when current is too high or when there's an imbalance indicating a fault. You don't need to be a physics professor, you just need to be comfortable applying these ideas to simple exam-style problems, like calculating current in a circuit or the power needed to lift a load. Okay, so a bit of a revision checkpoint. Can you define power in words and in a formula? What's the difference between series and parallel connections in terms of voltage and current? Name two types of electrical protected device and what they do. Next, let's move into measurement principles. Paper 2 will expect you to understand how area, volumes and quantities are measured for construction and services work. You'll come across linear measurements, so lengths of pipe, cables or duct. Then we have area for flooring, full wall finishes or insulation coverage. Volume for cement, liquids in tanks or air in a room. And rates like litres per second for water flow, cubic metres per hour for airflow. You might see a question when you need to work out the volume of a room from length, width and height, calculate the length of pipe needed for a run, including rises and drops and offsets, convert between units, like from litres to cubic metres or from kilowatts to watts. In T-level exams, the working out is often as important as the final number. So show your steps, include units and round answers as the question asks. Now, let's talk about information and data, a big part of modern BSE work. On the drawing and diagram side, you'll see schematic drawings for heating circuits, hot water systems, and electrical layouts. Simplified representations showing how components connect, wiring diagrams with terminal numbers and actual code routes, and symbols and abbreviations defined by standards so everyone reads the same thing the same way. Digitally, you'll come across BIM systems as data sources, storing information about components, performance and maintenance, digital controls for heating, ventilation and air conditioning units, using sensors and softwares instead of purely mechanical controls, and programmers in two senses. Writing software or using language like C or Python in specialist roles, programming a control unit, setting times, temperatures, and even schedules. You will also see topics like data protection and UK GDPR, keeping personal and project data secure. Threats like malware or unauthorized access, the importance of interpretability, different digital systems being able to share and use data reliably. For the exam, you should be able to define metadata, data about data, explain why standardized symbols are used on drawings, and give examples of how data from a building controls can help optimize energy use or plant maintenance.
Don't forget to hit that subscribe button.
BSE isn't just about pipes and cables, it's also about money and contracts. Paper 2 includes construction, commercial and business principles, which might feel less familiar but are just as important. Some of the key ideas include types of businesses, so we've got sole trader, partnership, limited company, costs, we have material costs, labour costs, plant costs, overhead costs and even profit. Tenders, quotations and estimates, different ways of pricing work, and cash flow, money coming into and going out of the business, and why delays in payments can cause massive problems. You might be asked to interpret a simple question and explain what is included, the impact of unexpected costs or delays, and why businesses need to plan for maintenance and replacement of equipment. It ties directly to your future career, understanding how jobs are priced, what affects profits, and why time, quality, and safety all link to commercial decisions. Okay, we've got a revision checkpoint. Can you explain the difference between an estimate and a quotation? What are overheads, and why does poor maintenance cost a business money in the long term? We've already looked at systems in previous episodes, but for paper 2 you need a clear mental map of the main BSE systems and their components. So for example, we have heating systems, wet, central heating, so we have boilers, pumps, radiators, valves and controls, open venting systems versus sealed systems, and different boiler types, traditional, system, combination or condensing. Hot water and cold systems, we have direct versus indirect cold water systems, vented versus unvented hot water systems, and private versus public supply, boosted cold water systems and storage systems. Gas systems, natural gas versus LPG, gas installation pipework, meters, emergency control valves and flues, ventilation and air conditioning, natural and mechanical ventilation, ducts, fans, filters, valves and grills, mechanical extract and MVHR systems, electrical technical systems, lighting and power circuits, ring and residuals, consumer units, protected devices, earthing arrangements, data and control cabling. You should be able to name a key component, describe their purpose, and outline the basic principles of operation for each system. Many Paper 2 questions are describe or explain style, asking you to join up names, functions, and even outcomes. Finally, let's pull in maintenance principles. This is where your knowledge of systems and safety meets long-term performance. There are two main types of maintenance. We've got planned preventative maintenance, or PPM, which is regular scheduled tasks to keep systems working efficiently and safely. Examples of this could be annual boiler servicing, regular filter changes on ventilation systems, periodic testing of fire alarms and emergency lighting, and rewashing taps to prevent leaks. PPM reduces downtime, extends equipment's life, and supports compliance with regulations and even warranties. Then we have reactive maintenance, which is also known as emergency or unplanned maintenance. Work carried out when something's failed, a leak's happened, a breakdown, or even a fault. This can be more expensive and disruptive because it isn't planned. You also have maintenance plans and schedules which set out which systems need maintaining, what tasks are needed, how often they should be done. Is that monthly, weekly, annually, or at specific intervals? Some systems need priority maintenance due to health, safety, or legal requirements, such as gas appliances and boilers in rented properties. Electrical installations need regular inspection and testing, drinking water needing Legionella checks, and fire detection and alarm systems require regular testing. Then there's the paperwork. Manufacturer's instructions tell you how to install, commission, and maintain equipment correctly. Then we have maintenance checklists, step-by-step tasks for servicing a system. Logbooks, which are records of what maintenance has been done and when, and job sheets and condition reports. Detailed faults found, parts replaced, and recommendations for any future work. When a fault can't be rectified immediately, maybe parts are on a special order or a back order, the engineer should make the system as safe as possible, isolate it and label it, inform the client or building user about the impact, update maintenance records and plans, and consider temporary measures if necessary, like portable heating or alternative water sources. Okay, our last revision checkpoint for today. Can you give me one example of PPM and one reactive maintenance? Why are logbooks and checklists important? How can poor maintenance create safety risks and extra costs? Okay, so that brings us to the end of this week's episode. So that was our second big Paper 2 revision session, looking at the science behind your work, how you measure and use information, the commercial side of construction, the key BSE systems, and how maintenance keeps everyone safe and efficient over time. Last week we finished off Paper 1 and kicked off Paper 2 with emergency safety. Today we're filling in the rest of the picture, how systems behave, how we plan and price work, and how good maintenance prevents small problems turning into major dangerous failures. Your next step is simple. Pick one of the areas from today, maybe construction science, BSE systems or maintenance, and spend 10 minutes with your revision notes answering the now test yourself questions at the end of each section. That's where you turn listening into marks. If this episode has helped your Paper 2 revision, make sure you follow the Copper Connection podcast, share this with your classmates or apprenticeship group, and let me know which Paper 2 topic you want us to drill into next. Paper 1 is done, Paper 2 is the focus, and every session you put in now is another step towards walking into that exam room with absolute confidence. I've been Chris Bailey, you've been listening to the Copper Connection podcast, and we'll catch you on the next episode.
We'll be back next week. In the meantime, please subscribe and thanks for listening.